Let's consider geometric sequences. Last year, under exponential math, we did a problem of this kind. You have 300,000 pesos in your account. Every month, the amount in the account increases by 4%. Find the amount in your account at the end of each month for 5 months. Let's therefore list what happens at the end of each month. For the sake of completion, let's consider month 0, which is the time when you just deposited the money. No time has elapsed. You therefore have 100% of 300,000, which is simply 300,000. At the end of month 1, you have 100% of 300,000, but in addition, you have 4% of 300,000, which is what the bank gives you. Putting these terms together as one, using the distributive property of algebra, you get 100% plus 4% times 300,000. The distributive property is shown here below. If you add two terms that look like A times C plus B times C, then you can take C common and then multiply that by A plus B. And that's what we have done here. So 100% plus 4% becomes 104%. 104% is nothing but 104% or divided by 100. That multiplies 300,000. In decimals, it's 1.04 times 300,000, which can be written just flipped as 300,000 times 1.04. At the end of month 2, remember that you have 300,000 times 1.04 in the account. But the bank gives you an additional 4% on that, which means you have a total of 100% of what you have plus 4%, which is again 104%. Using the same argument as above for the percent, you get this as 300,000 times 1.04 times 1.04, which becomes 300,000 times 1.04 squared. Extending this same argument to the following months, at the end of month 3, you will have 300,000 times 1.04 to the power 3, and so on. So at the end of month 5, you have 300,000 times 1.04 to the power 5. Now let's write all these amounts at the end of the months in an order. You can see the amounts written here. You may notice very quickly that each number is multiplied by 1.04 to get the next number. For example, 300,000 times 1.04 is multiplied by 1.04 to get 300,000 times 1.04 squared. And that's true for any consecutive pair of numbers here. This ordered set of numbers is called a geometric sequence. A geometric sequence, as we see here, is a sequence of numbers in which each new term is obtained by multiplying a common quantity called the common ratio with each term. So, in the previous example, what is the common ratio? We discussed just now that you multiply each term by 1.04 to get the next term, and hence the common ratio, which we call R, is in this case 1.04.